So today I'm going to be talking about significant figures and some calculations that we do with significant figures and measured numbers. So first, to start with accuracy. So accuracy is just the question of how close to the true value are the answers that I'm getting, or the measurements that I'm getting. So in this class, we have to be less than 1% away from the true value for it to be considered accurate. So the way I like to remember this is if someone makes up like some crazy statistic, like let's just say that someone said like 95% of people in Utah hate chocolate. My question would be, is that accurate? And what we're really asking is, how close to the truth is that statement? So a great example of accuracy with a target here is, let's just say I shoot an arrow and I get it right in the dead center. That's really, really accurate. But if I obviously shoot it farther away from the center, my accuracy is a lot lower. And then precision is a question of how repeatable are these measurements that I'm getting. And in this class, we have to have less than 1% deviation for it to be considered precise. So again, let's use a target. Let's say I take 3 shots at the target, and I can see here that my 3 shots are pretty close together. So I'm getting relatively the same values every time that I shoot. So I've got high precision. Now let's say one of my shots is farther away. So now my precision is a lot less because I'm getting different values, or values that are farther apart than I was before. Now precision does not mean accuracy though, because if I have my 3 shots that are pretty close together, no matter how far away they are from the center, I'm still getting the same values. So it's very repeatable. So I would still be precise. So here are some examples for us to go through. Okay, here's our first shot. So we can see that first of all, our shots are not next to each other at all. So they are not precise. Now look at the average. So like the average of where these values are. The average for these values is probably not going to reach the center. It's going to be a little bit off to the right, as you can see. So it's not accurate either. So on this target, we have neither accuracy nor precision. Oops. Going the wrong way. Okay. On this target, we can see our shots are really close together. So we're going to have high precision. However, they're really far away from the center of the target. So we have low accuracy. All right, here is our next target. Okay, so the average of where these values are, you can see if we were to like average out all of these shots, it's probably going to get us pretty close to the center somewhere in here. So it is accurate. However, they're not very precise because we can see that their shots aren't super close together like they were over here. So it is accurate, but not precise. Okay, and here is the ideal. So what we're looking for, both accurate and precise. The shots are really close together and they're in the center of the target, or they're really close to the true value. Okay, so if, let's just say, for example, I'm getting this result though, where I've got high precision but low accuracy, that probably is a sign that there's something wrong with our instruments or with like the procedures that we're using. So a great example would be if you're using a scale, maybe your scale isn't working correctly because you're getting really repeatable values, but they're just off consistently. Okay, now we're just going to quickly talk about metric prefixes. These are just things we need to memorize. So here's a list of all of them. So what I think is the easiest way to memorize them is to memorize these that are multiples of 3 first, and then to go back and memorize these that are just one exponent apart. So let's first start with these that are, as we talked about, multiples of 3. We've got 10 to the negative 12, 10 to the negative 9, 10 to the negative 6, 10 to the third, 10 negative third, 10 to the third, 10 to the 6th, 10 to the 9, and 10 to the 12. Okay, so the mnemonic I like to use for this is terribly gigantic monsters killed 1 million men napping peacefully. And so that would be for tera, giga, mega, kilo, milli, micro, nano, and pico. And I know a lot of people have issues with like the symbols. So the trick that I like to use is first that we know that tera, giga, and mega are all really big. So it makes sense we're going to use a capital letter for those. And then we're going to get to kilo, milli. Now we've got 2 M's, so it makes when we get to the M again, we're going to have it lowercase, so it's different. And we get to micro. So this is our third M prefix. And so at that point, I just realized I've used M twice now. And so I have to use a different symbol. So micro is new. So if you ever get confused about those, I think the best way to remember is just to write them out on a piece of paper and start from the biggest, go down to the littlest. By the time you get to micro, you realize you're going to have to use a different symbol and you'll know to use new. Okay. Now these are for our units that were one exponent apart. So here we've got 10 to the third, 10 to the second, 10 to the 1, and we've just got 1, or like the unit that we're in. 10 to the -1, 10 to the -2, and 10 to the -3. And the mnemonic for this one that I like to use is King Henry died unusually drinking chocolate milk. Or one that I think makes more sense to me anyways is King Henry died unexpectedly drinking chocolate milk. So again, here we've got kilo, hecto, deca, and then our units, deci, centa, and milli. So here we've got our K for kilo, H for hecto, and then deca. I don't really have a good way to remember this, but you're just going to have to remember that deca is DA. And then we have our units, and then deci, we've got D, centa, C, milli, M. All right. Here we put them all back together again, and you can see in the bold, these bolded ones here are the saying of terribly gigantic monsters killed 1 million men napping peacefully. And then here in the not bold, but we're going to start with kilo, is King Henry died unexpectedly, or our base, drinking chocolate milk. So hope that helps you remember them. Okay. So now we're going to talk a little bit about exact and measured numbers. I know we haven't talked about significant figures yet, but just an important note to make is when we're talking about exact numbers, significant figures do not apply. It's kind of like they have infinite significant numbers, or just don't even worry about it. So an exact number, or it's also if it's discrete, if that helps you understand a little bit better. There's a couple ways to find them. One is counting. So you know exactly how many apples there are because you counted them. There are 4 apples. You're not uncertain about that at all. Unless counting is hard. All right. And then also by definitions. So we know that 1 hour equals 60 minutes because that's what we defined it as. Like 1 hour doesn't equal 61 minutes because that's not the definition. So we're 100% certain that 1 hour is exactly 60 minutes. And exactly 60 minutes is exactly 1 hour. So no uncertainty. Those are exact numbers. Measured numbers or continuous numbers are measured. So anything that you're measuring in any experiment is a measured number. So significant figures are going to be an important part. And the important part about measured numbers is there's always going to be some level of uncertainty. So uncertainty means that the last digit of any measured number is uncertain. That means there's some amount of error in it. So let's look up here. Here we've got 2.55. Now we don't know exactly that that is 2.55 because there's not extra little lines between these two right here. So we know that that's 2.5, but we don't know where the 55 is. So we just kind of estimated, but we could be off by 1. So this digit has error in it. Now here, let's say that there's less little guiding marks for us to measure against, right? We don't know exactly where 2.5 is. We know where 2 and 3 are. So we had to estimate for 2.5. So this time, this 5 has uncertainty in it. So with measured numbers, the final digit has some amount of error in it. And that's what significant figures are going to help us deal with. So significant figures, it's not a 0. It is significant. If it is 0, it gets a little complicated. So here are some of the examples of when they're going to matter and when they're not, but we're going to go through them right now. Okay, leading zeros and trailing zeros. Okay, so leading zeros are not significant. So just to start off, I think if you think of the number 5, you could say 0, 5, you could put 0, 0, 5 or 0, 0, 0, 5, but no matter what, it's still just the number 5, right? So no matter how many zeros you put in front of a number before the decimal place, it's not going to matter. So I like to keep that in mind when I'm looking at these numbers. So here we have even after the decimal, right, we've got leading zeros, zeros that come before any significant number shows up. So they're not going to matter. We're just going to ignore them. So here we've got 2 leading zeros, and here we have got 1, 2, 3, 4 leading zeros. They're just not going to matter. We're going to ignore them. Now trailing zeros means it has to come trail after the decimal point. So if a 0 comes after the decimal point and a significant number, then it matters. So I kind of think of it like, say you've got a really, really famous person and then someone who is just a normal average Joe, right? If the average Joe walks out first, no one's gonna care about who they are. But if we have our famous person or a significant person walk out first, and then their friend like walks out with them, like falls right after them, people are gonna care because they'll be like, oh my gosh, you're famous by association type deal. So long story short, if it comes after the decimal point and a significant number, this 0 is famous by association, therefore it is also significant. So these 3 zeros here are significant. So here we've got our 2 leading zeros don't matter, and these zeros are significant. So we're gonna have 1, 2, 3, 4, 5 significant figures. And down here we talked about these leading zeros aren't significant, but this 0 is famous by association, so it's going to be significant as well. And I think it's just really helpful too to think about when it comes to trailing zeros. This first answer here would be just as quote unquote correct to write 0.024 and leave it at that. But they wrote the extra zeros there for a reason, so that must mean that they matter. Okay, captive zeros. All right, so when a 0 is stuck in between 2 non-zero numbers, it is significant. So basically, it's sandwiched between 2 significant numbers. It's going to be significant too. So a great analogy I like to use for this one is we look at this cute little girl here in our picture, right? She is not very intimidating. So I would say that her intimidation level is probably a 0, right? So by herself, it wouldn't be significant, right? But when she's surrounded by 2 very large dogs, those dogs are pretty intimidating. So suddenly her intimidation level goes up because she's sandwiched in between 2 pretty intimidating dogs. So, and that's kind of a weird analogy, but the point is that zeros that are sandwiched in between significant digits are also significant digits. So here, in this first example, we're going to have 3 significant figures. So we're going to have 4 significant figures. And then down here, we're going to have 5 significant figures. Okay, placeholding zeros. The only thing these zeros are doing is showing us the place value of our significant numbers. So there's no decimal place at all, as we'll notice. The only thing it's showing us is what place values these significant digits over here have. So if they're just holding 0 place, they're not significant, and we can ignore them. So all of those are not significant. So we have 4 significant figures. And down here, we've just got 1 significant figure. Okay, decimal captive zeros. Okay. So before we talked about how if you were sandwiched in between 2 significant numbers, so the zeros in between would be significant. Kind of the same thing here. So here on this side, we've got a significant number. And then here we've got the period. The period is kind of to me like an exclamation point. It's like saying, hey, this 0 matters. So if you've got a 0 before the decimal point, and it's sandwiched between another significant number, that 0 matters. Because normally when you have this number, right, we would just write 500. They wouldn't need to put a decimal point. But they put that decimal point there for a reason, which is probably that those zeros matter. So we've got 3 significant figures, 6 significant figures, and 5 significant figures. So I think this is really important to note, and I think we'll probably talk about on the next slide too. Let me double check. Nope. Okay. If that decimal point was not there, this would only have 1 significant figure. But because this decimal point is there, exclaiming that the zeros matter, now we have 3. So that's just an important note here. And the same thing here. So if we didn't have that decimal point, that would be 1 significant figure. If we didn't have this decimal point, this would be 4 significant figures. But because we do have the decimal point, these are what the significant figures are. Okay, so that's just a review of everything we just talked about. All right. So here is a great example, some practice to use. So let's start at the very top here. Okay, so here we've got two significant numbers and it is sandwiching this zero. So this zero is significant. And then here we've got this zero, and that's a placeholding zero. So there's no decimal point, and all it's doing is showing us that this 7 is actually in the tens place. So that 0 is not going to matter. So for this first answer, we're going to have 3 significant figures. All right, and now here to our second example. My mouse will help me out here. We've got another sandwiched 0. This significant numbers are sandwiching our 0. The 0 matters. And then here we have got a trailing 0. So I think remember we talked about, like, you could easily write this as 60.7 and leave it at that, but they added the 0 after the decimal place. It's famous by association. It's following its famous friend out the door. Therefore, it matters. So this is going to be 4 significant figures. And then here we have got, these are leading zeros. So they came before anything. They don't matter. Ignore them. Here we've got a sandwiched 0. So that matters. And then here we've got a trailing 0. So that came after the famous friends left the door. So they're famous by association. So these two zeros are significant. These two are not. So we're going to have 4 significant figures. And then here on our last example, we've got 3 trailing zeros. Not trailing, I'm sorry, leading zeros. So those don't matter. We're going to ignore them. And then we've got a sandwiched 0. That matters. So we're going to have 1, 2, 3 significant figures. Now, what's really cool about significant figures is if you write them in scientific notation, it's really easy to see how many significant figures they have. So you can see here, if you just count 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3. It's a really great way to know or double check your work. Okay, so now quickly to use significant figures and math. So for adding or subtracting, we're going to round the answer to the least number of decimal places. So here, this value has got 3 decimal places. This value's got 1 decimal place. We're going to go to 1 decimal place for our answer. So when we add these together, our calculator would actually give us 3.535, but we're going to round it to 1 decimal place. So we're going to have 3.5. Multiplying and dividing, we're going to round the answer to the least number of significant digits. Okay, so this number has 3 significant digits. This number has 2 significant digits. So when we multiply them together, we're going to round to 2 significant digits. And that's going to give us this answer here. Okay, this is not my example, but I saw, and I think it's a really, really good example of what to do when you have multiplication and division or addition and subtraction in the same problem. Okay, so first we can see up here that we're going to add 0.94 plus 0.98 plus 8.0 times 10 to the negative 2. And we're going to divide that by 4, 0.000. Our calculator is going to give us just 0.5, but that's not telling us how many significant digits there are. So first, what you're going to do is start at the top right. So at the top, we added these lovely numbers together, the numbers we just talked about right there. And when we add, remember, we're going to take the answer and we're going to round it to the number of the least decimal places. So this has 2 decimal places, 2 decimal places, and 3 decimal places. We're going to round it, as you can see, they show here, to 2 decimal places. So that's got 3 significant digits. So up here, we're going to say, okay, there's 3 significant digits, and then we're dividing it by, down here, we saw that there are 4 significant digits. So now I've got the question of why do we care? All right, let's say that we're going to calculate density. We would take mass divided by volume. Let's just say here's our mass, here's our volume. The calculator is going to give us this lovely long rambling number. But if you remember, significance figures tell us where the error is. Specifically that the last decimal of that measured number has some error in it. So with our new answer that we get from multiplying and dividing, adding, subtracting, we want to know where that error is now. So that's what the significant figures helps us track. So we can see, okay, mass has got 1, 2, 3, 4 significant figures. Volume has got 2 significant figures. And because we're dividing, we're going to take, the answer should have the least number of significant figures. So it's going to be 2. So this answer would be 0.34, or B. Okay, yeah. So that is everything. I hope that helped.